Welcome to The Explainer. Today, we're taking a fresh look at something we've all seen a million times in our textbooks, but let's be real, rarely truly understand. We are decoding math's visual language, and specifically, we're going to absolutely master the inequality sign.
So, be honest for a second. Do you really know how to read these signs when they just suddenly pop up in a massive equation? If you're the kind of learner who wants to finally lock this concept down without all that usual algebra headache, you are in exactly the right place. You know, most of us were taught that old hungry alligator eating the bigger number trick back in, third grade? And sure, that works perfectly fine when you're a kid just comparing whole numbers. But the second you throw algebra and variables into the mix, that imaginary alligator just leaves us totally lost. So today, we're ditching those childhood memories tricks. We're going to build a real, robust visual framework that you can rely on for the rest of your math career.
Okay, let's dive into this. To get it right, we have to start with the actual formal definition. An inequality is really just a statement about order or a directional relationship between two numbers or algebraic expressions. It's explicitly telling us if something is greater than or equal to, less than or equal to something else. The absolute key takeaway here is that inequalities are fundamentally about directional relationships. They're not about hungry reptiles. To truly grasp how this directional relationship works, let's swap the alligator for a much better visual metaphor. Imagine the symbol as a megaphone or a cone. It's so simple once you see it this way. The wide opening fundamentally means more than, and that tiny, closed point at the end means less than. It literally is that simple. If you're looking at the wide end of the cone, you're dealing with the larger value. Hitting the tiny point first, you've got the smaller value.
And it's super easy to build on this foundation. If you see a single solid line underneath our cone, that simply adds the phrase or equal to the whole relationship. But let's see how this cone visual actually works flawlessly with real numbers. If we read an equation naturally, just like a book, from left to right, we'd start at the 10. Immediately encounter the wide opening of the cone first, and then move over to the tiny point at the 5. So we're literally reading the shape. 10 is more than 5.
And this brilliantly illustrates why this particular framework is just so incredibly powerful. Because, in mathematics, direction changes absolutely everything. Reading from left to right gave us exactly what we just said. 10 is more than 5. But wait, what happens when we read it backward, from right to left? Well, we start at the number 5, hit the tiny point of the cone first, and then move across to the wide opening. So the exact same sentence becomes 5 is less than 10. Both statements are 100% mathematically true. It just depends entirely on which direction you're reading from.
Which brings us to a huge pivot in how we understand this stuff. The moment we drop variables into the mix, strictly reading from left to right isn't always your best strategy. So I want to dramatically emphasize what is essentially the ultimate math secret for algebra. Always, and I mean always, try to start reading from the letter X or whatever variable you happen to be working with. Make this your absolute golden rule. Wherever that X is sitting on the page, your eyes should dart right to it first.
Actually, scratch that. We can take this golden rule even one step further. Here's a secondary pro tip that's going to instantly translate those intimidating, complex mathematical symbols into plain, everyday spoken English. Instead of just reading the letter X out loud, try substituting it with the phrase, all the numbers that are. Doing this is a total game changer. It forces your brain to instantly realize that X isn't just some mysterious, static letter. It represents a whole dynamic set of possible real-world numbers. So let's walk through exactly how this looks in practice. If X is on the left, you start there, immediately hit the wide opening, and naturally say all the numbers that are greater than 5. Super easy. But what if the X is positioned on the right side of the symbol? Well, following our golden rule, we start our eyes at the X and read towards the left, hitting the tiny point first. So we just naturally say all the numbers that are less than 8. And if there's a line under it, again, starting at X on the right, we hit the wide opening and that solid line. It translates perfectly to all the numbers that are greater than or equal to 8. Do you see how perfectly that works? Starting with X never fails, no matter which side of the symbol it's on.
All right, time to level up. Everything we've tackled so far has been a single bound. An open-ended limit just stretching off into infinity in one direction. But the real challenge in algebra, the stuff that trips people up, is dealing with double bounds, where your variable is literally trapped inside a specific range of numbers. Now, what's really interesting about this is how beautifully our golden rule handles these complex compound inequalities. You see a variable trapped between two numbers, and what do? You don't panic, you start right dead in the middle at X, and you read outwards in both directions. Reading from X to the left, we hit the wide opening, so X is greater than 10. Reading from x to the right, we hit the point, so x is less than 18. Put it all together in plain English, and you get all the numbers between 10 and 18 exclusively, meaning 10 and 18 aren't invited to the party. But any number between them, like 12 or 17.9, totally is. And if you see lines under the cones, that means it's inclusive. It becomes all the numbers between negative 15 and 21 inclusive, so exactly negative 15 and exactly 21 are allowed in the club, along with the whole shebang in between.
Let's consolidate this whole lesson. As we review these final setups, there's one incredibly comforting fact I want you to remember. The visual rules literally never change. It doesn't matter if you're dealing with weird negative numbers, massive positive numbers, or super tight double bounds. That cone metaphor always holds true. Wide means more, point means less, a line means are equal to, and you always start reading from the X.
So this leaves us with one final thought. We've officially taken that hungry childhood alligator and replaced it with a rock-solid, visually structured, directional framework. You've got the tools, you've got the vocabulary, and most importantly, you have the golden rule. So the very next time you're staring down an algebra problem and you see an X staring right back at you, where are you going to start reading? I think you know exactly what to do now. Thanks for joining me on this explainer, and keep exploring the beautiful language of math.